So, good morning, Dr. Aloka. Am I audible?
Good morning, Professor.
So, I think we can start now. I have already introduced. So, today's topic of Aloka ma'am, she's going to give a talk on AI agents and Agentic AI for NLP applications. Now, ma'am, I have already shared the screen. So, good morning, one and all again. And I'm hand over the session to Aloka ma'am. I have already made you the co-host. You can share the screen and you can start the session. Thank you, ma'am.
Thank you very much, Professor, for the introduction. Since this is the second topic I'm going to cover in this workshop, so I hope those who have joined yesterday already know about me. So I'm a senior lecturer at the University of Moratuwa, Sri Lanka. So I will be conducting the session mainly on AI agents and agentic AI for NLP applications. So let me start by sharing the screen. Right. So AI agents, agentic AI for NLP applications. So we are already familiar with what is NLP and what are NLP applications. So let's take the agentic approach on how to address the same NLP applications which we have been solving. Right. So the agenda for today. Right, so we will look at what is artificial intelligence and how it has progressed. And then we will dive into what is agentic AI. So these agents are not really new, but agentic AI is new. So let's try to understand what has already been defined with the current literature and how it has changed the perspective of AI agents in the modern world. And then we will look into what architectural support is there for agentic AI applications. Then we will look at the stages, and we will look at a simple workflow on using AI agents. And we will look into some NLP applications, and I have one hands-on session as well. I can demonstrate the implementation and execution of an AI agent. Right. So artificial intelligence, the term was not, although it picked up the hype recently, it was introduced in 1950s, right? So it's all about how to make machines intelligent, independent of human intervention, right? So early stages of AI was symbolic AI, or basically rule-based, right? So it was all about how we represent knowledge, and then how the agents how these machines are capable of executing and making intelligent decisions. Right, so this is what gave rise into machine learning, which was popular or gained popularity in 1990s. Right, so they are using statistical models or functions. Intelligence was inculcated into machines. Right, so therefore now at this point it was data driven. So given the data, it learns from the data to do better predictions for newer examples. Then picked up the deep learning approach where the reasoning was based on neural networks. So the same data we can give to a deep learning neural network, and when the model is trained by means of parameters, it will know how to make the appropriate prediction or the generation, etc. So now we are in the generative AI era where the decoder-based models are capable of generating responses by means of chats or by means of human interaction, right? So now the most recent one. So how we can streamline these LLM, or else how we can inculcate the autonomy for these agents in order to address a industrial or some kind of a real world application, right? So this real world application may be starting maybe from the industry or maybe from academia, or it can be from some other background as well. So it's all about how we can automate um, agents to work by interacting, right? So starting with a single agent, we can go up to complex agentic systems where it will be a multi-agent environment where they will execute step by step and make these steps dynamically in order to achieve a goal, right? So this is where we are. So let's look at some definitions. So, yeah, so let's look at these two terms, AI agents and agentic AI, right? So, as I said, AI agent or agents is not new. It has been introduced somewhere back in 1950s, and then progressively it had emerged up to now, right? So, an agent in the view is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. So this is the early definition of agents. So when we say agents, it's not only LLM. So in this particular scenario, so agents can be autonomous agents, can be robots, or can be simple machines in order to execute execute a task, right? So these agents are very reactive. So they were early stages, they were based on rules. So they perceive the environment, if it's a temperature, if it's a temperature sensor or temperature adaptation, it reads the temperature that is in the environment, and based on condition, it will increase the thermostat, or it will increase the temperature of the uh, uh, it will of the heat. Right. So so more recently, like in 1995, so it was all about how to make it autonomous, right? So these agents, if we act on rules, not all the environment can be represented by means of rules. So therefore, the agent should be able to take decisions and achieve a goal. So autonomy has been a really important factor in an agent. Right. So a more recent definition by Anthropic. So agents are systems where LLMs dynamically direct their own processors and tool usage. So now these agents are not only capable of perceiving from the environment and input from the environment, now it's actually It's actually learning to interact with other systems, other tools, other APIs in order to achieve the goal, right? So that is basically in the manner of AI agents. So we take the agentic AI approach when so this is a shift compared to traditional system where it is aimed at generating responses to autonomous systems that can independently plan to achieve goals with minimal human intervention. Right? So here the decision making, the dynamic decision making power is with the AI agents. So they interact in order to achieve a task. So here also it's the same approach. So we have looked at some definitions. So an AI agent, right, can perceive the environment and can reason, and making use of the context can perform an action, right? So what kind of a example can we think? Now if we take the chat GPT, everyone is familiar. If we say, tell me the weather, right? It gives an answer. Then if you are not satisfied with the answer, the human has to re-enter follow-up question. But if there's agent capability with the LLM, we can ask, check the weather, schedule umbrella reminder, and notify user. So there are several tasks now the agent has to manage, right? So first of all, it needs to identify the weather, right? So depending on the weather, if it is a sunny day, then such a reminder is not necessary. But if it's raining only, then the reminder has to be scheduled, and on the correct day should be sent out to the user. So as you can see, there's a sequence of tasks which has to be independently managed by the human. So there's no way inside in the workflow there's going to be a human interaction, right? So only at the time of giving the input and only receiving the notification, right? So this is the capability that we want to inculcate into the AI agent, right? So then when it comes to agentic AI, the task is more complex. So this requires the integration of several agents, or else in a multi-agent environment, we expect the agentic approach to be taken, right? So there, in addition to LLMs, they can make use of tools, or else, and also it is important to learn based on the generated feedback, or the generated response is taken, it is evaluated, it is checked for factual correctness. Then this opens up the trustworthiness of AI agents, and then whether it's safe, right? So we talk about safety of AI agents. So whether the response is safe, trustworthy, factually correct. So these are actually very good measures to verify before really sending out the response or the final outcome to the user, right? So if we take it as a simple flow, we give it a goal, right? So maybe to find the cheapest flight and make a reservation, right? So then it has to know that where to find the flights on the internet or from some particular URLs, airline URLs. Then it has to do some comparison, some mathematics is involved. So after the comparison, then it should act, right? So what is the flight to be selected, and also make the reservation, right? And then observe the results and gather the information and final step is improvement, right? So it works in a loop, right? So maybe it collects the flight fares, and then it checks whether there are furthermore websites, or it checks whether um, whether there are any other conditions linked with the fare, right? So likewise, it will improve its reasoning and the final output. So when designing agentic AI systems, now there are several architectural supports. So this is in addition to, so there can be much more in the future. But if you take this particular uh, uh, architectures, most of the systems can be handled using this architecture, right? So the simplest is a reflection pattern, and then it can be the agentic AI architectures also supports multi-agent systems as well, right? So agent swarms even are possible, right? So likewise, the complexity grows in this architectural designs. So let's look at one by one. So for what type of architectures these agents, what type of architectures uh, we have to go for when it comes to the scenario, right? So always this architectural decision is important, right? So anything complex, we might not be able to solve it using a very simple architecture. And at the same time, anything very simple, there's no need to complicate either, right? So this is a design choice. So it has to be this architecture is really important to determine and identify, so that the final result or the final output will be correct. So first one is the reflection pattern. So that's the simplest form. So the reflection pattern lets AI review its own work to find mistakes and improve. It's like AI checking its essay for errors before submitting, right? So likewise, let's take an example. So we ask the AI agent to generate a report on climatic change, right? So maybe a report or a essay, right? So then we can specify the number of words, and then the agent will generate the report. So then in the same agent, there should be, so it generates its first output, right? So then it has to be, there is a reflect LLM, might be a same LLM or a different LLM acting as a critic in order to check the correctness of this essay. So it might be checking for the factual correctness, or else it might check for the grammatical errors, spelling mistakes. Likewise, there will be several checks. So if it is not, if the reflect agent identifies the any errors, then it will re-enter its feedback to the LLM and ask it to regenerate, right? So likewise, this will loop, and maybe after 2-3 cycles, finally, the user will have a very good essay to submit, right? So this is the very simplest form, where the only verification we introduce is to uh, check for errors in the generated output. Then there's so this might not be, so in some cases, only the LLM output might not be might not be able to be determined for correctness by a judge, LLM judge, or a critic LLM. So then we might have to use some tools, right? So tools can be in the context of this essay, can be spell correctors or grammar correctors, or maybe performing a internet search to get the facts, right? So likewise, several other tools will need to be called by the LLM, right? So from this agent, right? So therefore, this is another architectural design that that is available with the tool integration, right? So, for example, if it's a mathematical problem, so this kind of tool support will be needed, right? Because sometimes LLMs are not good at mathematical operation. Some API which supports mathematical operations will need to be integrated. So this is for specialized knowledge. So going beyond, the third type of architecture we have for AI agents is react pattern. So this is reason and act. So most of the time, these are reasoning models which access the generator, right? So the generator will take step by step the reasonings, and then it will evaluate the possible choices, maybe by the support of tools or maybe by external environment, and will improve the response, right? So here the difference is that we can also use the tools and the environment support, but most of the time these generative models are having the reasoning capability. Right, so now let's visit, we will see an implementation of an AI agent. So this AI agent is supposed to write an essay, right? So this is the prompt the user gives, right? Write a 5-paragraph essay on, you can give the topic, right? So when we implement, it's important to identify what frameworks are available to implement this AI agents or agentic workflows. So we will look into that when I'm going through the code implementation. So at a high level, what I want you to understand is this case study where I'm trying to build up some simple understanding on AI agents. Right. So write a 5-paragraph essay. Then there will be a generator node. So node is like a graph, right? So I think all of you are familiar with graphs, right? So a graph will be having nodes, and it will have arcs to show the directionality, right? So each of these nodes can be determined as the subtask, right? So the full task is generating an essay. So we are trying to generate now, break it down into several subtasks. So we are trying to now break it into several subtasks, and we are going to define nodes in our graph, right? So the first node That's why this generate node is there. So we are going to define our first node as getting the prompt and generating an initial essay. Right. And then there's going to be a condition. There's going to be a conditional node where we see whether it has to end or else it has to loop, it has to go into some more improve, right? So, right. So in this case, we are going to limit the generation part with some number of iterations. So maximum of 2 iterations, maximum of 3 iterations we are going to use, right? Or else someone else can say, no, I'm going to run this for 10 iteration and going to get a better essay. Right, so this condition for continuation can be checked by means of number of iterations or else by a evaluation metric. Right, so then if still the number of iterations is less, then it checks and send the essay to a critic. Right, so critic or this may be another LLM, right? So this may be another LLM which will, so we call this as reflect node. It's also another node, right? We are going to basically check the correctness of the facts or correctness of the grammar, correctness of the spelling, right? And then if then it generates a feedback, and here now the second time generation node is going to get 2 things: the original prompt the user has given as well as the feedback of the reflector, right? So therefore we need to execute this agentic workflow, we need memory, right? Memory or state, which is going to hold all this information. The prompt, the human given prompt, and also the system generated feedback, right? So then it will again iterate, it will again generate a revision of the essay. And if it has reached the number of iterations, it will return the final essay, right? So this is what the user is going to accept. So this is a very simple workflow by means of len graph. So now let me share this. Okay. So this is the implementation. Right. So we need few libraries in order to implement it. So LangChain is basically to implement a node, right? So in this particular slide I drew, so there were several nodes. So each and every subtask in the node can be implemented using LangChain. And LangGraph is another library which is used to create the agentic workflow, right? And then I'm going to use another library, LangChain OpenAI, because I'm going to use a LLM for generation and also to generate the reflection or else the critique feedback. Right, so I'm going to use OpenAI or Open Router support LLMs. So in this case, now I'm going to use just a free given model, right? So I have not paid anything. So you cannot, there are several models which can be used for free, right? So you will have, there are several ways, right? Not only the open router, right? But also if you want to directly access Google, Gemini, so these API keys are personal. So you will have to generate. So I won't be able to use the API keys. Right. So here I'm just showing you some ways you can access LLMs, right? So if you want to create access Google-based LLMs, so you have to go through the chat Google Generative AI module in this library coming under LangChain. You have the you have the LangChain Google Gen AI, and in that you have the Google supporting module, right? So you have to visit. So this is also very cheap in the sense it has a free tier. You can do 15 requests per minute and 1,500 requests per day. Of course, in the free tier, there is some limitation. And you can generate a API key by visiting the AI Studio, google.com, and you can start using the LLM. Right. So another alternative way is to access models directly from Hugging Face. Right, so in Hugging Face there are open source models, LLMs, and then chat-based ones, right? So they can be accessed using the LangChain Hugging Face library, or this particular library, and you can access all the models available in the Hugging Face. Again, you have to go to the Hugging Face web account. You need to, against your Hugging Face account, you have to generate the API key. Right, so there you have Mistral models, Llama models, etc. And yeah, so this is even Gemma can also be can be accessed through Hugging Face. Anything on Hugging Face, you need the Hugging Face API key. But anything else will need the specific key. If you are using ChatGPT models, you will need the OpenAI key in order to access those paid models. Right, so I'm using Twin in this particular scenario. So I have also generated the API key, right? So I have, therefore I can access this Quinn model from Open Route, right? So Open Router, we know it's a platform again where LLMs have been hosted. Right. So now we will start building our first node. So that is the generator node. Right. So in this generator chain, now we said the node definition will take place by sequence of fixed steps. So there it has the LLM. We initialize the prompt and we say what is the LLM to which it should be sent to, and then we get the output, right? So it's simple as that. That's exactly what that particular node will do. So here we are now going to generate a system prompt. Right now, human will say, I want a essay of 5 paragraphs, giving the title. So there should be a system prompt to say that you're an English expert, or if you're a high school graduate teacher, and then you can define your specific role or specific system prompt in order to support it, right? So by doing so, you will be sending the prompt, the LLM, say which LLM it has to be passed into, and get the output. So here we are just defining the node. Then we are ready to define the reflect chain. So reflect chain is also a node which is going to now take the reflect prompt, right? And then it's going to use a LLM and generate a output, right? So here, in addition to the reflect prompt, right? So we are appending also the generated output from the generator, right? So that is passed through the state. Therefore, the state we define in the lang graph is going to handle that part. Right. So what we are telling uh, the reflector prompt is, again, it's going to be a system prompt. You are an essay grader tasked with grading essays and providing feedback. Evaluate structure. So here you can define your parameter rather than saying is it a good report or is it a bad report. The more precise you say on which criteria the LLM should evaluate, you will get a better critic. Right. So the reflect chain is going to just pass, going to use the reflector LLM and the reflector prompt. Then we are ready to define the nodes. So here, now I said the always this node is going to get the state, or some who is going to get the context that is set. So initially there won't be a context, right? But when it comes to the reflection node, the context will be the generated essay, right? So when we define the nodes, always we define it for the state, right? So this message is going to contain the history or the conversational history. Now, if we are doing this for the second iteration, it's going to accumulately keep the generated essay, given feedback, the revised essay, the given feedback, likewise everything, right? So then we have a router node. So this is where we want to take the decision. So for how many times this loop should run, right? So we can define this as maximum iterations 3. So now with these defined nodes and the functions, we are going to define the graphs, right? So for the graph, we are adding first of all the nodes. Now we have only 2 nodes. The generate node, which is defined by the generate node function, the reflect node, which is defined at the reflection node function. So these were implemented here. So we need to say now for the graph, what is the entry point? So entry point is the generate. Then we have to add a condition to determine what is the iteration and whether to proceed or not, right? So should continue function is now going to be linked as the conditional edge, right? And then always, then we are going to define the edges, right? So there should be edge between reflect and generate, right? So conditional edge between the generate and the should continue function. So likewise, we have now completed defining the graph. And then we compile, right? So at the time of compilation, it is now ready to execute the workflow, right? So now the user enters the prompt, write a 5-paragraph essay. Then, so we are expecting some mark. So now this is the response, right? So the response is going to get the output of the workflow, right? So now after executing, now I said that once after the this response is going to contain all the states, the iterations, all the states and the generated output, etc. Now let's see the output, right? Okay. So input by the user, write a 5-paragraph essay on importance of AI ethics, right? So then draft 1 is the LLM output. Now 5 paragraphs, 1, 2, 3, 4, 5 has been written, right? So then what is the uh, output for this, right? So critic initially has not responded. There's no second draft. So now the critic has, in the second step, the critic has given its evaluation, right? So then it is, LLM is now generating a revised version, right? Thank you for your feedback. Now this has been restructured, right? So likewise, after several iterations, it will improve the essay, right? So this is how to simply define graph to create a essay, right? Now, now this is also an NLP application, writing essay, but it's coming from education side. Now, for the research side, what type of for what type of work can we use the agentic approach, right? So here, now let's say I'm working with languages Sinhala and Tamil. So now the intention of this AI agent is to generate more data, right? Which is to augment the data, right? So we have Sinhala sentiment classifier data set. We have only 500 examples. Then how do we define a agentic workflow in order to improve the data, right? So you start with the initial data set and maybe translate English, something from English back to Sinhala via agent, right? So this is another subtask, and we can do paraphrase, right? So for the initial sentence, there's a fixed label. So now when we paraphrase it, we can generate 5 more for the existing one, right? And then we have to check for the correctness. Now, okay, we have paraphrased, but is it going to have the same sentiment, or is it going to be factually correct? So there should be some quality filter. Again, that is a subtask. Again, for that we can use an AI agent, maybe some tool. And finally, we have augmented data set, right? So we can keep on repeating until we get the desired number. So this is a very simple workflow which can be followed for data augmentation. So this will be the architecture to follow. Okay. Right. So I'll discuss one more NLP application. So question answering, we all know, right? So user gives a natural language question and get an answer generated by maybe a LLM or can be a knowledge base, right? So the workflow, right? So user generates a question, maybe in English or in the native language, and there should be a retrieval agent which will do information retrieval and identify the potential documents having the answer. Then we can do a context injection, right? So top K relevant passages can be added to the prompt, right? So we shortlist 5 or 4 and we can now do a ranking of these retrieved documents and we shortlist and we send it again with the user's query to another LLM to now generate the answer. After that, there can be another LLM or using the same LLM, we can check for the correctness of the answer, right? So this is the basic workflow of the basic workflow for a QA agent. So here, in order to store the web documents, we can use RAG, right? And then the retrieval augmented generation can be used in order to shortlist the number of documents which has the potential answer. So why RAG is suitable, right? So otherwise, we have to do a full fine tuning of the LLM in order to get the desired answer. Inference wise, it may be less costly, but training wise, RAG is much more cost effective because it's not requiring any fine tune. And then we using RAG, we can also preserve the language agnostic nature because we are not going to specify a language, right? We are not going to fine tune a model for specifically for Sinhala. Based on the technique, based on the input query, we may determine the language and retrieve the subset of the documents and do a comparison. Other than that, there's no need for the system to be limited to the language. Right. And it is easily updatable, right? So if we have the knowledge-based documents up to last year, right? So we can release that version and then we can work on collecting the rest of the document and update. Whereas if we go for a fine-tuning approach, we will have to retrain the entire model with the expanded documents, right? So therefore, this RAG approach is easily updatable as well. And it further reduces hallucination. Why? RAG is going to, based on the relevance of the retrieved document, it's going to define the, it is going to reduce the hallucination as well. Otherwise, so the LLM will use its own creativity and generate an answer which might not be factually correct. Therefore, RAG further conditions the answer with factual correctness. And then scalability, right? So the scalability is good because we can keep on expanding this for other low resource languages. Right. So now what are the other open questions we have? So there's long needed models to be deployed on edge devices, right? Because these LLMs to execute the agent workflows, we require the internet if it is hosted on cloud services. But we need more and more edge deployable models or agentic workflows so that the internet dependency can be minimized. Or else we can use agentic AI to build standard and evaluation datasets. So for NLP benchmark datasets, we can take this approach. Then cultural aware agents. So this cultural awareness is limited in LLMs, right? So we have to now introduce the cultural knowledge to the LLM, how to give this. So we can make use of cultural aware agents in order to further improve the response to adapt the culture. Then collaborative data collection, right? So design agents that assist communities in annotating and curating their own language data at scale, right? So this can be supportive to provide it may be supportive as a assistant. Agents can act as assistants in annotation tasks as well. Interpretable agent decisions. So research explainability in agentic pipelines. Why did agent choose this action for this language? So this is also another research domain where we try to justify or we try to explain what is the agent's reasoning behind following a particular flow in order to give a output, right? So we expect through the agentic AI to dynamically get the agent to take decisions, right? So why that decision was taken or what made the agent to perceive that path can be justified through interpretability, right? And then offline first agentic NLP build systems that leverage local models for privacy preserving and no internet required NLP, right? So that is also important, right? So moment it's on cloud, the data is not with us, right? So therefore, if we want to have more closed models, more private models, which preserve sensitive data, organizational data, or institutional data, right? So then we can go for this offline first agentic NLP models, right? So these are some of the directions where you can see how to take up these agentic approaches in terms of these NLP domains. So the summary. AI agents are autonomous systems that perceive, reason, and act, right? So going far beyond single step AI, right? So single step AI, we give a question, get an answer, that's it. But no, now we are giving the capability for an agent to actually review its answer and generate a better response, right? So number two, agentic AI uses tools, memory, iterative planning to handle complex and multi-step tasks. So because of this uh, capability of distributing the complex workflow into subtasks using this modular design, this is possible. So low resource NLP language face data scarcity, morphological complexity, and limited pre-trained models. So we can use agentic approach as a way of adapting these pre-trained models into our own languages. Agents address these gaps through data augmentation, RAG, fusion prompting, multi-agent pipelines. So these are solutions how we can address this NLP problem specific to low resource languages. So real gains have been demonstrated for certain low resource languages, so even in the research papers, so it's promising, right? So open challenges are cost, error propagation, evaluation benchmark, and cultural alignment. So yes, sometimes running several iterations might be costly if you're really accessing specialized domain models, or else in the workflow, if there's an error which happens with the initial LLMs, it can propagate into the final response, right? So these are problems where we can try to minimize during the execution of the workflow, right? So this is also uh, going to be important. Yeah, so this is now not only for Sinhala Tamil, we also do for other languages, right? So this agentic AI approach is promising. So I have one question, I think, in the chat, asking for a collab notebook for the Q&A. But I have not prepared for the Q&A part, mainly because I did not have a suitable data set to showcase for Sinhala. But the capability is there, and there will be research papers which has taken this direction. So, but
Ma'am,
I
in this RAG agent low resource Q&A, ma'am, in the updatable part, uh, we have seen in many websites they use chatbots which will help you for your personalized issues. So they eventually lose memory about what you are saying, and often they don't know the context. So how should we use RAG agent properly, or should we maintain a lot of memory in this case?
Yeah, so
Because
that's a very important question because yes, the more context we have, we can give a better answer, but we have to also think about the cost aspect as well. And like more context we have, sometimes the differences in context also lead to inaccurate predictions. So the more we use different other LLMs or chatbots, we lose the the proper, I mean, coming into a proper answer. So I would say, so if there are fine-tuned models, better to use them, or else we have to evaluate how much of context to uh, incorporate into the workflow, right? So they might be generating a response. So we can look at several responses and evaluate and then take it. Or else we can measure how similar those responses towards the query, and then decide how much, what are the response which can be really taken in. So without some validation part there, we might end up getting wrong answers, where the LLM will just try to do something creative rather than giving the correct answer. But that of course needs fine tuning, I mean, very careful experimental uh, experiments to run to evaluate and see what is the best working model for this particular case. Otherwise, if we just get LLMs to give their opinion, then definitely the problem you stated will happen, because we are just getting the response and let the generator generate it based on the additional context we have input. So context engineering, there's something called context engineering, which is very important in such situations. Yes. So thank you very much for that question. Will there be any other questions?
Any other questions from any participant? You can unmute yourself. You can ask the questions. So definitely ma'am will be there. I think after the workshop also, you can connect to me so that we can start some work in other languages. Because almost all the Indian languages are low resource, coming under low resource, right? So like that, any state students who are studying in KIT or outside also, we can start some work. And definitely for other countries also, African continent also, many of the languages are low resource coming. Almost all the languages are coming under low resource. So we can implement these things with the help of them. So any questions from anyone?
Ma'am, I have one more question. Like, how should we augment data properly? Because in India, there are many languages where two words mean the different in different languages, and our agent might get confused if we do for multiple lingual languages. For a monolingual language, it might be correct. How to make our model suitable with proper data augmentation for the words which have the same meaning, not same meaning, different meanings.
Yeah. So one thing we can check in data augmentation is the correctness of the final sentence. So whether based on the usage, whether do a context validation, whether when we do a data augmentation, I mean, syntactically the sentence might be okay, but semantically it might not be correct. Or else we can check it specific to the language as well, right? So we can say like for one language, but for that, it is better to make use of linguistic tools. Uh, we might need the support of more linguistics tools, such as, if there's a word net or if there's a tree bank, you might be able to incorporate them. So let's suppose when it comes to a different other language, if the same uh, context or the same phrase is giving a different meaning, so as long as that particular phrase is attached to a single language, it shouldn't be a problem, right? But so if there's a different meaning that you want to generate from that augmented sentence, then some other validation will need to be taken place. So that particular validation can be checking for semantic correctness depending on the language ID. So that is external knowledge, where we can try to further do a factual correction, further do a sentence correction specific to the language.
Yes, any other questions? Okay, I don't think so. Any questions are there? Thank you, ma'am. Thank you very much. I'll be connected with you.
Thank you very much, audience, for the questions. And thank you, Professor Satya, for arranging this workshop. Thank you very much.
Okay, thank you. Thank you to all. Again, we'll join at 12 o'clock. So one of the resource person from Portugal, he is going to join. Thank you very much.